So here we go. Let's take a look at this warm-up, and then we'll talk about the elemental Euclid real quick, and then the move on to the intersecting dimensions. All right. So name all the lines that are skewed to. This should, by the way, have a line over it here. Let's try that. To DH.
Wait, why is
Okay.
it arrows?
Well, this black thing right here, is that a line or a line segment?
Line.
That is a line segment. Does the line DH exist?
Yeah.
Yes. All right. So when we're talking skew, we're really talking about the whole line that goes on forever. All
So,
right. It exists. It's not drawn in. We've got this line segment that gives us an idea of where DH is.
what's the answer to we put the arrows?
Technically, yeah, because we're talking about lines, not segments.
Okay.
Okay. Symbols are important. All right. So coming around, I mentioned to a few of you guys. On your line segments or your lines, make sure you have bars and arrows, and rays have one arrow, right? And planes, we just have to write the word plane out, P-L-A-N-E. Okay, so like this, plane, A-D-H. So make sure you have them labeled correctly. If you just put, D-H or A-D-H, and we don't know what we're talking about, because we're going to be talking about triangle A-D-H at some point, all right? And so if you just put ADH, we don't know if it's an angle, a triangle, a plane. What are you talking about? All right, so keep that in mind. All right, so what do we got? We got DH is this thing going up and down here. Whoa, can't draw very well. Let's try that again. Okay. A little better. Okay, so give me another line that's skewed to it. Yes. AB is skewed to it. Very good. Throw another one out there, someone. FE? Okay, good. So AB is kind of going front to back there. FE is skewed to DH, okay? Now I'm going to draw this in here. Is FE skewed to AB? No, but we're just wanting to know what are lines that are skewed to DH. So FE or EF, doesn't matter which way you say it, is. Okay, cool. Somebody else give me a different one. Yeah, go ahead. All right, so very good. We got FG. That is skew. Okay, it's in the back of the cube, FG. Even though in the drawing it looks like it crosses DH, it doesn't. Yes. BC, very good. BC is back there. And we got BC. All right, a couple more. Avery, let's go give someone else a chance here. Okay, Trevin, do you got one there? Do we have? Anyone else see some that we don't? Okay, you go. We got the ones you got. That's cool. Yeah, what do you got, Aaron? EH. So EH. Well, EH will touch at H. You see that? Because EH is along the front. Okay. We got the one on the back there. It can't be AD. It can't be EH. It can't be GH because that touches at H, right? And it can't be DC because that touches at D. So there's one more. CE. Yeah, that's going kind of diagonal through it. Yeah. Okay. So we can talk about CE. So CE is kind of going diagonal like that, while DH is this one. Okay, cool. And I'll put that down below, but let's not worry too much about the diagonal ones because that'd be a whole bunch. There's one more that's drawn in, one more side. CE is a great one. Good job. But what's the one more side? Chelsea. BC. That's right. Oh, we already had BC. I just didn't draw it in. Yeah, I just didn't draw it in. Okay, so maybe we do have them all. There they are. Okay, cruising along here. Name a line that's parallel to ADH. So we can have lines that are parallel to planes. Okay, so we can have lines that don't cross. We can have planes and lines that don't cross. So Marissa, where is plane ADH? You tell us where it is. Top, bottom, left, right. Okay, good. On the front, cool. So ADH is the front. So can you give us a line that is parallel to it? A line that never crosses that? I'm sorry, say it again? BCG. That would be a good plane that's parallel. But we're going for a line. So let's just pick two of those letters. BC. So BC is a line that never crosses the plane that's in the front. Okay? Question?
Can another skew be AC and EG?
Sorry, say it again.
Could another skew to problem number
Yes, okay, those are the diagonal ones, but we're not going to
okay.
worry too much about the diagonal ones.
So that would
Sure, that would work. That's fine. Yeah, AC is diagonal. We could talk about a bunch of diagonals, but we'd have a whole bunch more, and we get the idea. So, like another line that's parallel. There's one more that's parallel to it. Yes, Sonia. CG. Yes, that's another one. Okay, and all along the back, right? You didn't have to get all of these, but these are all BF. These are all good options, and then FG. And we could talk about some diagonal ones, right? Anything on the back there, okay? Cool. Moving on. Name the intersection of plane BFC and plane EFG. BFC, where's BFC? Top, bottom, back, right, front, left. BFC is the back. BFC, okay? And EFG? FG. So EFG is the bottom down here, right? Okay. So BFC is the back, and EFG is the bottom, all right? So where do they intersect? FG, very good. And it's a line, FG, okay? Describe the plane DCG. Where's that? Top, bottom, left, right?
Right.
Right, you're right. Okay, and last but not least, plane, shade plane BCE. So BC and E. Oh man, I give you another kind of tricky one. Oh, that's not that tricky, but it's kind of going, whoops, kind of going slanted through here. So from B goes through C, goes through E, and so it's going to kind of look like this. Okay, so kind of a hard one to shade because it's kind of coming towards you, but there it is. Any questions? All right, let's cruise along here. Real quickly on the back of that handout, let's look at elemental Euclid.
What's the Malmbrot
It's a fractal.
fractal?
Fractal. Okay, we're going to go kind of quick here so we can have time to get on to some stuff. Okay. Okay. 3 points that are collinear. Okay. We can do a couple. We can do I, B, and F, or we can do J, C, and G. Okay. Put commas between these because they're points. If you don't put commas, they look like lines or something like that. Okay, those are the only combinations you can have. Okay. Find 2 other points on FGJ. Well, plane FGJ is FGJ. That's back here. Okay. FGJ, that's back here, and kind of keeps going up the back here, kind of like that. Okay. So it's the back side. So name a couple other points. We got I, and we have B. Those are the other ones. Find the plane that goes through the bottom of the cube. Name it in 3 ways. All right. This one's a little tricky, by the way. Go ahead and make some corrections. In fact, go ahead and go start this habit. Go ahead and pull out a pin here when we make corrections. Okay. Part of the reason for that is this little routine. Did I get something wrong? C. Yes, sorry. C can also. Very good. But when we're correcting things, let's go ahead and do it at pen for a couple reasons. One, if you are absent, don't just copy things down. We didn't have anything for this time, but don't just copy things down. Go home and do it on your own. Okay? Also, if you correct your own work in pen, you did it in pencil, then you can go look back at it and say, oh, that's right, I missed this problem. Oh, that's right, I missed this problem. And then when it's test time, you look through your stuff and you say, I missed those. Can I do them now? And you ask yourself that question, and hopefully you can. all right? But if you just change it all in pencil, you look back and I said, oh, I got it perfect, I'm so smart. Oh, I got it perfect because it's all right. Oh, I got it perfect, I'm going to ace this test.
Yes.
But you really didn't know half those problems, and you didn't study them, and you're going to miss them again on the test. Does that kind of make sense? Okay? So please correct your own work in a pen there. I don't care what color it is, okay? But make corrections, make notes, all that stuff, so you can look back at your assignments when it comes to test. Okay? All right, there you go. That's the idea. So we'll do assignments in pencil. We'll check it in pen. Okay? And I won't give that speech all the time, but that's kind of the idea. All right? Very good. Find the plane that goes to. Oh, so another one you said was C. C is also on the back there. Thank you. Find the plane that goes to the bottom. Name it in 3 ways. Plane. You have to write the word. There's no fancy symbol. Plane P. Okay. So there's no point there. P is not a point. P is the name of the plane. Okay. Or we could call it plane E F G, or plane H G F. 3 letters. You can name it with 3 points or this P. Okay. If you didn't put plane P down there, please go ahead and make that note. Okay. So.
EHF.
Yeah, the order doesn't matter, all right? And some of us said EFG, EGF, GEF, and said those were our 3 ways. Well, the idea is to use different points and to know that you can use the P. Okay?
So do you put a line over it?
No line. No line. It's not a line. There is no symbol, so we write the word plane. Okay? So that word should be there. Name 2 pairs of parallel lines. Okay, there's lots of them. So we could say CG, which is in the back. And one symbol I don't think we talked about, or maybe we didn't write down because we were going too fast. Okay, this is our parallel symbol. All right, so you can add that in there on your pairs. So CG in the back is parallel to BF. Okay. All right. Someone mentioned that we didn't write these symbols down. Shame on me. From the other day. All right, but those are parallel. EH is parallel to, down here in the bottom, FG. Okay. All right. So on and so forth. Questions? There's lots of others. I think we're okay with that. Skew lines, all right? 2 lines that are skewed to AD. Well, we kind of just talked about that in the warm-up, but so we'll go kind of quick here. AD is right here. And so a skew line, well, CG is skewed to that. That's one. Whoops. GC, CG, doesn't matter. That's another one. Throw it out there. How? GF? EF. EF is good, yeah, because EF is going away from us. Okay? EF. What you got?
Did you say JG?
EF, JG. Yes, JG, which is the same thing as CG. Okay, good point. They're both on the same line. So if I say line JG, that is exactly the same as line CG. Okay, we're talking about the same things, just call them different. Like I call you by your first and last name, or your middle and your last name, and I'm talking about the same person.
2 lines, did you say CG and JG, or?
Well, okay, that's kind of
CG.
the same answer twice. Okay, so, all right. Cruise along. Okay, there's others. Okay, but we won't list them all. Now, name 2 lines that are parallel to AD. Well, we got lots. We've got BC. Okay, there's AD. BC is parallel FG and EH. Okay, any of those. All right. EH. You only needed 2. FG. And that, whatever that other one was. BC. Okay. All right. And then we have 2 opposite rays. Well, remember, rays go opposite direction. We have from C to J, and C going through J, and then C going through G. Those are 2 rays going in opposite directions. Okay, and those are the only ones you can name here. CJ, and they have to be like that. And C, what was it? G? CG, yes. Okay. All right. I changed this for second period. I didn't change it for you, but shading that plane EDC, that's like we said yesterday. Well, that's kind of a hard one to shade because it's kind of back here, and And you can't really shade it, so I should have picked different letters. It's just hard to shade. So
For the opposite race, could you use IB and BF?
let's see. IB. IB and BF. Okay, you could. I guess kind of the intention is arrays that are drawn in here. But you're right. We can say it does exist. Okay. And so that's fine. Okay. Better would be just assume ones that are drawn in a problem like this on a test or quiz. But you know, you could say, hey, there is an array, and yeah, you're right, there is one. It's invisible. Okay, cruising along. Okay, 3 lines that are skewed. Last but not least. Okay, a lot of us had trouble with this. 3 lines that are skewed to each other. That line is skewed to this line, right? And can you find one more that is skewed to the 2 lines I just drew? What is one that is skewed to the 2 lines that I just drew? Let's give Jared a chance. Hey, Jared, can you see one that?
Yeah.
Good. So BF in the back, standing up, straight up. Okay. It doesn't touch this line because it's in the back, right? So there you go. C, D, E, H, and BF. That's one example. C, D, B, H, and E, F. Okay. Did I get that right? And E, H, right? I messed up, right? E, H, B, F. E, H, and B, F. Okay. All right. And, you know, technically those are lines. There's others, but do you get the idea that those are 3 lines that are parallel or skewed to each other? Okay, 3 lines that are skewed to each other. Could we draw a 4th one now? Let's stick with those 3. Is there one more? Is there any more that are drawn in that are skewed? Is AD skewed to all 3 of those? No, it's going to run into this one, right? Is AB skewed to all 3 of those? No. But is there one, Zach, that's skewed to all 3? AG. Very nice. So going diagonal. So we can come up with a 4th line that is skewed. It's just not drawn in. Okay. So let me kind of do it like this. Okay. So we kind of got that line. Not the straightest there. You see it? Okay, it's going diagonal through the middle of it all there, and it's not going to touch any of it. So yeah, we could. So that's AG. Okay. I put that in the wrong spot. Let's put these down here in pieces. No, good question. No, there is not. Okay. So CD, EH, BF. And AG. All right, so it is possible. There we go. Okay, good. Let's leave that alone. All right, because we've got to cruise along. We're eating up a lot of time, but we're getting. Oh, before we leave that handout, though, go back a page and let's do our symbols that we forgot because we were going too fast.
Going too fast.
Okay. Here we got some parallel lines, so you can sketch some quick parallel lines, and we would say AB, and we saw the symbol a second ago. That's our parallel symbol to CD. All right. Perpendicular.
That symbol.
Yeah, it does. Okay. Let's say A, B, C, D. Okay. Something like that. You might not have room. You can draw it down the bottom if you want or something like that. Okay. So these lines are perpendicular. This is our 90-degree angle symbol. That symbol means it's a right angle there. Okay. And we say this. Let's call this segment AC. You could call it AB if you wanted to. And this is the perpendicular symbol. An upside down T because of its perpendicular lines. And BD. All right. and NA, not applicable, not available. No symbol for skew. Okay. Well, let's leave it at that. We've got that down good. So go ahead and put that aside. Let's go back to the intersecting dimensions here.
Yeah.
All right, little assignment update. So that page 19, we're going to finish up anything that we need for that. It's a pretty, hopefully you'll see it's a pretty simple assignment. By the way, again, when you're doing your assignments out of the book, okay, when it's not a handout, please do copy the problem or abbreviate it. It's a big wordy thing, you know, like name 3 intersecting lines in the drawing to the right. You don't necessarily need to write that, but you could write 3 intersecting lines, 3 skew lines, or something like that. Okay? So write down the idea of the problem. If it's a simple, small problem, just write the equation or whatever. Okay? And then answer it. So anyways, page 19. So that's going to be due tomorrow. We got an assignment there for Thursday. We'll get into it hopefully a little bit, but that'll be due on Friday. I'm sorry. Thursday's assignment will be due on Monday. We'll probably have some time in class to work on that thing. Okay? So you might want to bring your books tomorrow there if you don't have them. So. All right.
Challenge.
What's that? Do you have any challenge? No, challenges are optional there. Okay? And yeah, they're optional. In fact, here's what I'll do. If you do for the challenge problems, I'll let you substitute that for the other problems. Oh, yes, you need a book. Okay. Yeah. Is the internet home? Okay. At the end of class, let me show you how you can get online. And that's my fault. I was supposed to grab your book. Okay. So I'll get your book by tomorrow. Okay. Yeah. You don't have a book. Okay. Let me talk to you about here at the end of class. Okay. So before you go. All right. So yesterday we talked about these postulates, right? Where we ended. A postulate is just something we accept. It's very simple. We don't argue about it. It's just the way that it is there. Okay. So a postulate, the 2-point postulate says that if you pick any 2 points, you can draw a line through it. Okay. The 3-point postulate says if you have any 3 points, you can't draw a line through them necessarily, but you can have a plane that goes through them. They're on one plane. Okay, or a plane goes through them. All right, so part C there, I think it's on the back, right? So now we're going to talk about the intersections. What happens when one-dimensional and two-dimensional things intersect with each other? All right, so I'm going to turn it over to you because I've been yapping at you a whole bunch here. Okay?
Yes.
And so let's do this. Take a few minutes here together and describe these things. When these things intersect, what does the intersection look like? Is it a point? Is it a line? Is it a plane? What do they look like? Okay? Do they intersect at 2 points? So on and so forth. Okay? That's what we're looking for. All right, so go ahead, take a couple minutes, and answer those together. Go for
Wait, I don't want to.
No, it's always like this. Parallel.
Pull down. How fast would you like to go faster? Yeah. Right.
All right, got some ideas? Let's see here. Let's intersect some things here. Okay. Two non-parallel coplanar lines. All right, so they're on the same plane. Okay, so they're on the same plane. They're not parallel. Okay, but tell me about their intersection. What will their intersection look like? What kind of object? Okay, they make an X, but what do they share in common? What do they share in common? What's that?
A point.
A point. What do you think?
That's what I was supposed to say.
A point. Okay, you guys agree?
Yeah.
Okay, so they intersect at exactly one point, right? Okay, so where they cross is a point. So we have two lines that intersect. Uno, dos. And what is the object where they cross? They touch at exactly one point. Will they ever touch again? Ever come back around?
No.
Nope. All right. So it's a point. Okay. Describe the intersection of two non-parallel planes. So we have two planes that intersect. Okay. So if we've got two planes that intersect, like so, where will they touch? At exactly one point? No, on a line, okay? So they touch right here, and they go on forever, remember, in all directions. So they touch on a line. Okay, very good. So the intersection of two planes is a line. Okay, describe the intersection of three non-parallel planes. So if none of them are parallel, okay, so here I have two that are not parallel, and I take this one that's not parallel, and it comes, imagine it slices right through. Where will all three of them touch? On what? Well, these two will touch at a line. Okay, if you can look at the crease where these two, and these two will touch at a line. Okay. And there's a line through the middle. What do you think? It is a point. It's that point right in the middle there. Okay. Another way to think of it is like this: the corner of a box. Okay. The bottom is a plane, the side is a plane, and the back is a plane. And where do those three planes touch? Right there. At that vertex, that point. Okay. So three non-parallel planes will intersect at a point. All right. And describe the intersection of two coplanar lines. Okay, is that the same thing? Oh, okay, describe the intersection of two coplanar lines. Same thing. Two non-parallel coplanar lines. Okay, well, okay, I guess here we didn't say it's non-parallel, so we could say a point or no intersection. Okay. So I guess that's just a bad question. Bad question. Bad. Okay. So I guess since we didn't say they couldn't be parallel, so I guess we got two answers. Anyway, don't worry about it. Describe the possible intersections of a plane and a line that's not on the plane. Okay. So here we have a plane. Okay. And here we have a line that is not on the plane. This line is on the plane. Okay, it's laying down on the plane. Okay, this line is not. Okay, so what are possible? Could it not intersect? Ever? Yeah. It could be parallel, right? And it could never intersect. So it is possible to have no intersection. Okay, so let's try that again. No intersection. Is there anything else possible? Is it possible to touch the plane?
Yeah.
And so where would they touch? Let's see the plane. Okay, imagining that this ruler was a thin line, okay, where would they touch? Exactly one point, right, which said back there. Yeah. Okay, so they would touch at a point if this was not parallel. Or 1 point. Those are the only two possibilities, okay? If it's not on the plane. Okay, so here we go, postulates. So after thinking about those things, we got some very simple postulates, okay? How many times can two lines intersect? Well, once, right? They'll never come back around, okay? That's simple but important, okay? If two lines intersect, they'll always intersect at exactly 1 point. It's just saying the same thing, okay? So that is the postulate, okay? This is the postulate. By the way, we're going to have lots of postulates and theorems. We'll have numbers, postulate 1.2, okay? You don't need to memorize the numbers. That doesn't matter, okay? If it has a name, the two-line postulate, that means it's pretty important, okay? You guys get names when you're born because you're pretty important, okay? Kind of remember the name and the basic idea, all right? How many times can two non-parallel planes intersect?
0.
For example, are they ever going to cross again? That's what we're looking for there. Will these ever cross again? And if they're not parallel and they cross, will they ever cross again?
No.
No, they'll cross once, right? Okay. Just once. Yeah, go ahead. Yeah, go ahead. Okay. And so if they do intersect, how do they intersect? We already said it. A line. Okay? At exactly one line. Okay? That's it. Once. O-N-C-E. Once. Once. Okay? I guess you could say once. And I don't think that's right. Okay. Okay, so go ahead and take out your book if you got it. If you don't, no sweat. Now, actually watch this, okay? And especially Matt, watch this because that's what I'm going to do. Okay, let's say you go home, you say, oh, I forgot my book. I can't do my assignment, which is on page 19. Okay, well, no problem. On your syllabus, okay, there is a link. Okay, it's called PearsonSuccessNet.com. That's on the bottom of your syllabus, bottom left corner. Okay? And you can go there and you can type in this very complicated password. GP Geometry.
That's the password.
And the password. GP Geometry. Okay? Watch this. Yeah, that is, I think that's down there, right?
But what do you see on the computer?
Well, then this won't work. Okay? Then you go here. Okay? You guys see that one? A lot of people get to this point and they say, I logged in and I didn't know what to do. Or I didn't want to know what to do or something like that. Okay? You'll get to this screen. It says PH Math 2004. That's our book. That's the date it was published. It's a little old. We click on there. A lot of times I won't put the page number. Okay? Usually I won't. In fact, see on Thursdays. By the way, 1.4, it's there on Thursday, but it's due on Monday. You're not going to be able to do it. Well, I mean, you can look ahead. It's not hard. But you don't need to do Thursdays and Sunday. Okay? Get the page 19 done. Okay? So, anyways, if you know the section number, you can go there, or you can go here and you can type. There we go. You can type the page 19. Okay, did I get it? 19, go. Okay. Okay. it's not there. You gotta go down to this exercises here. So there's a couple clicks, but if you get this down, you might not have to take your book home, okay? But you gotta go down to the exercises, and it's coming up there, okay? So that's the process if you want to use the online page, okay? Easier thing, just take your book home and look at page 19, okay? But here's what I want you to do. Quick look ahead here. We're looking at 21 to 31, okay? Got to draw name lines that are parallel and skew, okay? It's like we've done, nothing too hard, okay? So on and so forth, okay? Thanks, guys. Have a great day. We'll see you later. So, okay.
Oh my God, I'm tomorrow. Oh yeah, yeah.